Okay, I want to do a quick simulation so you can see how the process to find the sample average and the sample proportion are different. So I have this particular situation at the moment, and it concerns the length of human pregnancies. And I can see here that it's approximately normal with a mean of 366 days and a standard deviation of 16 days. So what I want to do right now is sample from this distribution, and I will simulate this using Excel's random number generator. So I'm going to click on data, and off screen here you can't see it, but once I click on data to the far right, there's something called data analysis, and when I click it, this shows up, and I'm going to check random number generation. I'm going to click OK. The type of distribution is normal, and I'm going to enter 266 for the mean and a standard deviation of 16 days. I'm going to do a simulation where I sample once, and now how big is my sample? How many numbers are in my sample? Let's say there's just going to be 20 numbers. So my sample consists eventually of an average of 20 numbers. My random seed is just a number between 0 and 32,000. I click here, output range, and I want the computer to put my data in A1. So now I'll click OK, and it will simulate sampling 20 times from this distribution. And there are my 20 numbers. Now, when I'm talking about sampling distributions of means, I'm talking about every possible sample of 20. I just happen to have one possible sample of 20. So if I continue with the process, what I would want to do is average this set of 20, and I will get my one number that belongs to all possible numbers that consist of an average of size 20 from this distribution. So I happen to get an average of 272.12, and this is just one average out of a bunch of averages, a myriad of averages that come from doing the process you just saw, sampling, then calculating the average. Okay. Now, how does this differ from proportion? In a proportion, and if we're using a binomial type condition, we need to define what success is. So let's say for a moment that success is this. Success is a number from my sample is, let us say, 275 days or more. So that is what a success is. Now I have my data, and I need to determine if this number was successful or not. So I look at this first number, and I can see that it wasn't successful. The second number was successful. This next number was not successful. This one was, nope, was, no. And now let me automate this. So what would happen next is I need to count how many successes I have. So I'll count how many successes. So I'll tell the computer, look, if the number on this side happens to be greater than, let's say, well, should have done equal to, but oh well. The chance of getting exactly equal to are remote, so I'm not going to worry about it. So if A1 equals 20, greater than 275, then I have witnessed one success. What happens if I don't see that? Then I'll have witnessed 0 successes. So the first one, of course, will be, that first one is not a success. It doesn't count for a success. But now I'll let the computer do the rest by moving here to the right-hand corner, dragging down, and now I'm counting the number of successes. And let me pause because the phone is ringing. So now, what will I do? Well, shoot, I do the same thing I did over here. I just calculate the average. Because what's p-hat? P-hat is nothing but an average, but it's an average of nothing but ones and zeros. Basically, I'm just counting the number of ones and dividing by the total amount that I observed, and I got 0.65. So this number is p hat. But the other one here is y bar. So if y measures the length of human pregnancy, then this number is an average of 20 numbers. It gets y bar. This is p hat because these measure or count how often I get success. And that's the difference.